Hello and welcome to the video lecture on join indexes. Join indexes are, you're probably going to be better off identifying a join index with an associative entity. Alright, because that's essentially what it is. A join index speeds up join operations. What are join operations? Join operations are when I want to see, I've stored my data, I've normalized it, right? So in this case, I've got customer as an entity, and I've got store as an entity. In this case, they've been changed, they've been made into tables. You'll see something interesting here, which you probably haven't seen thus far, is something called a row ID. You can look at row ID in one of two ways. You can think of it as an enterprise index, which means it's unique amongst all of the tables involved in this database. Or you could look at row ID as it is in Oracle as actually the location on disk of where that record begins. One way or the other. But I just don't want to confuse you. I don't want you looking at this saying, hey, wait a minute, what are these row IDs? So let's look at these tables. So we have customer number, which for all intents and purposes is the primary key of the table, of the customer table. And then we look at store, and store number is more than likely the primary key of that table. Unless, of course, we're using row ID. But so a join index for non-key columns. So for instance, we've got city, and quite often we're going to want to link up and find out how many customers are associated with the same location as the store, right? So I want to see, I've got stores, right? I've got 4 stores. I'm going to want to know what customers of mine live in the same city as those stores. So we would join these two tables on city. We're going to get into that more in chapter 6 when we deal with SQL. Actually, in chapter 7 in the advanced class. Probably not even going to get into joining in the introductory class. But in order to make that faster, in order to make that happen faster, and we talked about how joining tables is a production hit. In order to make that faster, we can create a join index that you see on the bottom. So we store the common value, and then the what looks just like an associative entity. Right, we've got our combination of customer row ID and our store row IDs. The combination of those two will make it much faster for us to join these two tables together. The other example, we're using the join index for matching primary keys and foreign keys, which is much more common. So in this case, we're using the customer and the order scenario. Again, there are row IDs here. So what we're doing is we're saying that the primary key is the customer primary key, and that's being used as the foreign key in the order table. And then again, we can use the row IDs associated with those customer numbers to join those two tables together quickly. So that is essentially what's going on with join indexes. Again, these need to be maintained. So if you have these in place, always, whenever you think about your data storage, you got to think about two different things. There's data entry and there's data retrieval. So on the join indexes speed up the join operations, which is data retrieval. They slow down the data entry. And that is the end of my video lecture on join indexes.